In this video, I'll show you how you can quickly and easily analyze a large data set and make a nice figure using R. I'm Maria Nadestad. Learning R allows you to analyze your own biological data without the limitations of Excel and without waiting for a collaborator. By learning some computational skills, you can control every stage of your data analysis. If you have a hunch about a pattern in your data, you can explore it yourself without waiting for someone else to do it for you. For biologists, R is by far the most productive language you can learn. R is focused around data sets in a way that traditional programming languages are not. That also means that it takes a special touch to work with R and not against it. It just doesn't act like the other programming languages at all. Once I figured out how R wanted me to use it, it became much more smooth for me to do data analysis with it. Now, R is the data analysis tool that I use for all of my own research. I want to share with you what I've learned along the way, and just remember that for each tip I show you, even if it looks elegant, it's usually because I have spent hours figuring it out in the first place. My hope is that this will save you some time and frustration so you can focus on your own groundbreaking research. And you can feel confident knowing that when a computational challenge appears, you will be ready. So let's get started. So this is a quick example of how to get started analyzing a small data set in R. I have a folder here that contains my data set as a .txt file and my script for making the plot, which is a .r file. So this is the file that contains the code that we're going to use for plotting the data. And that always has to end in .r for R to know that it is actually code. So first I'm just going to open the data file, so our variant data.txt. So this is a list of variants, and it'll open on your computer probably in maybe a different text editor that you have, maybe text edit. But since it's a .txt file, it should open in something that makes sense. So each line of the file here is a variant, and you can see it starts with a chromosome number in the first column, then a start position and a stop position, which are sometimes different. And then we have a type for the variant, so this is insertion, deletion, expansion, and contraction. And finally we have the size of the variant. So now we know what our data looks like. Let's see what happens when we import it into R. So what I'm going to do is open up RStudio. So you should have R and RStudio installed already. And we're going to open up RStudio. Then what we can do is go to File, Open File, and load in. If we go to Desktop, we have our example here. And here is the R file that we have built already, and I'm going to open that. And now what we need to do is make sure that we're in the right place so that we can actually find the data too. So what we do is we explore this place in RStudio a little bit. First of all, at the bottom here we have the console where we can type things in, and it'll execute it right there. And we also have a place up here where I can execute commands as well. This is a script, and so if I execute a command here, I can do Command Enter, and it'll execute it, and it's almost like it copied and pasted it down here into the console too. So we don't want that. So that shows you just how to do that. And over here we actually have 5 different tabs, some of which we're going to use today. And the one we're going to go into right now is Files. So here we should try to find the data that we have. So what you can do is go to Home, and your desktop will be in here if you're on a Mac. So you go to Desktop and find the folder where you put the plots. And so here we select our variant data.txt, and we can actually load it in right here, and it pops up next to our other files. So we have the R file here, the script, and we have our data right here, and so we can look at it from here too. And now that you're in the right directory, in the right folder on your computer, you can go up to More and say Set as Working Directory. And you can see right here it actually executed something, and so this is RStudio helping you out, setting the working directory for you, and actually running the R code that sets this working directory. So you don't have to worry about that, but just by going up to More and set as working directory, we're now in the right place that when we try to load in a file just by saying variantdata.txt, it'll actually be able to find it in this folder because we are in there. Next thing we have to do is install any packages that we might want to use, and in this case I'm going to use a plotting package, which is awesome, that is ggplot2. So what we do is we go up to the tab up here that says packages, and we go install ggplot2, type it in here where it says packages. It should pop up with the name, otherwise you might have spelled it wrong, and then you click install. And since I already have it installed, I'm just going to go cancel. And now in every script where you're going to use this package, you just start by saying library, parentheses, and then ggplot2. And that'll show it to actually load in that code so that now you can use it. Otherwise, you have a lot of code loaded that you don't necessarily need. And this is also a great way for you to tell other people what plotting packages and any other analysis packages that you've been using for your analysis. So we always have library and then whatever package we're using. So what we can do is actually run this. So just like with the 3+3 before, I put my cursor on this line and I hit Command and then Enter. And you can actually see at the bottom here that it pops up and says library ggplot2. And if you notice, it took a second before this greater than sign came back and said, now you can type more. So when that's done, or it pops up, but if it's still running something that you've done, maybe because it takes a little while longer, then it's not going to pop up yet. And so you know that R is still working on doing what you asked it to do. So what we'll do now is read in data. So we have here a function, and we have a variable, and we're assigning whatever we get from the function to a variable. So let me explain that. My data is a variable that we're going to use to contain all of the data from that variance file that I showed you. And the way we get the data in there is by using this arrow right here. So it's a less than sign and then a minus. And that is going to tell it to take whatever is on the right side and stick it into whatever's on the left side. So it's essentially just transforming the myData variable to containing the output from this function. So read.csv is a function. It is code that other people have written that we can use to do things so we don't have to write them ourselves. And so this is a really neat function because it reads something called a comma-separated value file. And the funny thing is, we don't actually have a file that has comma-separated values, but this function is so nice that it actually gives us a way of saying that we're using tabs instead. So I'll show you that. But first here, we have to put our file name in quotes, because that way we're telling it that variantdata.txt is the name of the file. It's not a variable like my data. If it didn't have any quotes, R would try to look for a variable called variantdata.txt and it wouldn't find it. So instead we put quotes around that to say that this is just word for word exactly what you should look for, not a placeholder for it. So then we do comma to say, okay, we want to feed this function a few other things. The next thing we want to feed it is the separator for that file. And here we have quotes again, so we do separator, or sep, equals, and here we have this funny /t, which is actually meaning a tab. So this is the slash that you have above your enter key. And so if you do /t and put quotes around it, that indicates not a funny t, but a tab in your file. And since we looked at our data, we'll open it again, and there's tabs between them. You can tell this because they're all lined up so neatly down the lines. We have tabs separating them, and that means that we need to put in this sep equals /t in quotes. Very important quotes. Comma means, okay, let's feed it one more thing. So this function needs three different things here. It needs the file name. It needs to know what our separator is, assuming it's not a comma. If it was a comma, it would just make that assumption and it would be right. That's great. But since we don't have a comma, we'll put in a tab. It's always best to just say what your separator is so that someone reading your code would know what it is you're requiring your files to have when you read in data. And then we do header equals false. And that's because when we look at our data, we can go back up to it up here. We see that there is, in fact, no header row that tells you what each column says in it. And so we say header equals false. Awesome. So what we're going to run, what we're going to do is run that. So we say, we put our cursor here on the line, and we go Command, Enter. And so that runs it. Another way you can run things is by highlighting the whole line, and you can run this as many times as you want. It's not going to break, because it's just going to run it over and over again, and you keep reading the same data, so it's totally fine. So let's take a look at what this data actually is. You can actually highlight it, by double-clicking or whatever you want, and just execute that one part of the line. So when you have it highlighted, you go Command-Enter. And so that executes it. And when you execute just the name of a variable, what it'll do is print out everything in the variable. And in this case, it's an entire data frame full of things. So it's a little annoying to print out everything. And sometimes you have a lot of columns, so it kind of bleeds over and it looks really bad. So something we can do is go, I'm typing up here in the script, we can go head my data. So this is another function. And this function lets you look at just the top of your data. So we go Command-Enter again. And now we can see that we have the top of our data here. And it has this weird V1, V2, V3, V4, and V5. So that looks like it actually made column names for us, but that's not what we want the column names to be if we're going to be working with the data and asking it questions. We don't want to have to go back and say, well, I want all the columns where V5 is greater than a certain number, and you have to look up what V5 is. No. We want to rename the columns so that it makes sense. So a function that we can use to look at the columns is names of my data. So this just means column names by default. So we execute that line, Command, Enter, and now it says V1, V2, V3, V4, V5. So anything that it prints out is going to be down here in the console. Alright, so we know what that is, but let's actually try to replace that with our own names. So we now have this head my data, which actually is really great because it shows us what we want each one to be. So we know that the first one is chromosome, then start, then stop, then the type of the variant, and then the size of the variant. So perfect. And in R, in order to make a list of things, you just need this C and then parentheses, and you separate each element in the list with a comma. Super easy. So if you want to run just that to see what it looks like once it's read into R as a variable, or if it was a variable, you execute that line, or just that part of the line, by going Command Enter. And so this is a list. And if you do the same thing on names my data, you can see that both of them are lists of size 5. They have 5 elements in there. So what we can do is replace names my data with this arrow with the other list. So when we run the whole line, either by highlighting all of it or just placing the cursor on the line and go Command Enter, now we have run that code. So, okay, let's see what our data looks like now. We go head my data, and now we can see what the top of the data looks like again, but now with the right column names. At this point, you can check to make sure that each column has a name that makes sense, because if you have a little error where maybe you switch some of them around, it should be really obvious right now when you have them lined up with each variant type. Cool. So now we've got a really good grip on what our data looks like. It looks very neat, and the next thing to do is to plot it. And so we can use ggplot for this. With ggplot, you use the function ggplot, that's easy, and you put in first the data that you have, and this is my underscore data, and then this AES means aesthetic, and so that really corresponds to what do you want your data to be represented as in the plot. So the example here will explain that much better. So here, x equals size. That means that on the x-axis of the plot, I want to put the size column from my data. Alright, so next, the fill color, fill, in the plot, is going to be the type in our data. And so you can tell that we're using the column names here. So we want x equals size, meaning x-axis is the size of our data, and the fill, or fill color, is the type in our data. Cool. And so we end the parentheses on the ggplot here, and now it's almost like we're doing math. We're adding to that something. And so in this first part, there's actually nothing that says what kind of plot do you even want. So what you do is you say plus, and then you indicate what kind of plot you want. And you can find the rest of these in the documentation, but geom_bar means I'm making a bar plot. And we just need these parentheses afterwards because this is a function, just like the other functions we had, like head and names and read.csv up here. They're all functions. So this particular function just doesn't have anything inside it, but you can also add something inside it if you want. If you want to give it more parameters to tell it what kind of plot you want or what you want it to look like, you can add some of those in there too. And so now let's run this line in the code. So we go Command, Enter, and let's see what we produce. So we have a plot popping up over here. Looks great. And you can see that it's automatically picked colors, which actually look pretty good. And each type, over on the right side over here, we can see the legend. Each type has a different color, and it automatically just picked them. It automatically made a legend for us that says contraction, deletion, expansion, insertion. Great. And it actually labeled the x-axis, and it chose good limits on the x-axis. So like it automatically chose a top limit that is kind of a round number, but also includes all of our data. So that's great. And it did the same thing on the y-axis. And on the y-axis, it even labeled it count so that we know what this means, because we never told it what the y-axis should be. By saying geom_bar, it automatically becomes a histogram, because of the type of data that we put in. You can also make a categorical bar chart, but because we made x equal to size, which is a numerical variable, it plotted it out like this. If it was categorical, it would be a bar chart, so you could actually have different types down here, for instance. So there's all sorts of things you can do with ggplot. If you found this video useful, it would really mean a lot to me if you would share it. And please comment below and tell me why you are frustrated with your own data analysis. If there's something in particular that you want to learn, comment and tell me that too, and then maybe that will be the next video that I make. Thank you!